Today in this video, we're going to continue. Oh, sorry, my bad. Today in this video, we're going to continue on our CCIE RIP version 2 trip. Last time we talked about RIP basics. Now we're going to talk about convergence and loop prevention with RIP version 2. So let's get into it. I got this chart straight from the Cisco Press CCIE Route Switch version 5 book. And these are important topics about RIPs, convergence, and loop prevention. Counting to infinity, basically when a route reaches 16, stop using that next hop. Split horizon, if I hear about a route if I hear about a route that comes into an interface, I am not going to advertise that route out that same interface. All right. Then a stronger variant of split horizon is with poison reverse. Yes, I received a route incoming this interface. However, I'm going to advertise that same network out that interface, but with an infinite metric. That is if poison reverse is implemented with split horizon on your router. Then route poisoning, it's when if a route fails, I'm going to immediately send an infinite metric to my neighbors, prompting its rapid removal from the routing table. And then triggered updates says the immediate sending of a new update when routing information changes instead of waiting for the update timer to expire. So like I said before in the basics, RIP will send an update every 30 seconds. But what happens if something changes? Well, I'm going to send an immediate update rather than waiting 30 seconds. So that's what that's all about. Now we have all these timers, okay? And when you're taking the exam, especially for the written exam, you have to know what these timers are and what they actually mean. So we have the update timer. Basically, how often am I going to send an update? By default, it's 30 seconds. Invalid after. This is, by default, 180 seconds. However, this is just like EIGRP's hold down timer. Don't get confused with this hold down timer. Invalid after is just like EIGRP's hold down timer. If I don't get an update with that route for 180 seconds, I'm going to move on to the next step. So that's what invalid after is. After 180 seconds happens, we will move into the hold down timer now. Now this is a whole new timer, and we have 180 seconds after the invalid after timer. And what this happens is once I reach the hold down stage, I'm going to start advertising that route that I didn't hear for 180 seconds. I'm going to start advertising it as unreachable. And I'm going to lock down the routing table. And this is where I'm going to see in the routing table, route is possibly down. All right, I have more on that. I have more slides on that. Then we have the flushed after timer, where when I actually remove this route from the routing table, it's going to take a total of 240 seconds. All right, so as soon as I get an update, boom, my flushed after timer starts at 240, and then it counts down to 0. All right, and I have a slide on how the hold down timer will never reach 0 because the flush after timer will hit first. All right, more on that. All right, so critical information about RIP version 2 and path selection. For each network, a router will choose the neighbor with the least total metric as the next hop and install it in the routing table. This is the big thing. All other routers with a high metric will be ignored. Like, it will receive it, but since it already has a route with a lower metric, I'm not even going to install you in my database, which I think is weird. But when I was doing this in the testing environment, I was like, why don't I have other routes? Why don't I see it in the database? And after I read it, I'm like, oh, well, I guess that's why. So if the next hop router advertises a higher distance than before, RIP will accept that immediately and increment its update accordingly. So only if that next hop sends you an update, and first of all, that route was already in your routing table, I will accept it. If another router that isn't my next hop sends me a update with a lower metric, I mean, I'm not even going to respond to it. All right. Logic here is if my next hop has changed its metric, so has everyone else. So that's why it ignores everyone and only listens to the router or the next hop with the lowest metric. Okay. Here is how counting to infinity happens, especially when split horizon is disabled or not enabled. So here in this little topology, network X is, or network N is over here. router 1 will advertise this network to router 2 with a metric of 1. All right. Then without split horizon turned on, or without it enabled, router 2 is going to send it back to router 1 with a metric of 2, and then it goes back and forth. Router 1 will then send it back to router 2 with metric of 3, 4, 5, 6, and this counts to infinity. If there wasn't an actual number for infinity, then it would actually go up to infinity. But however, it's only going to go up to 16, and that's where it stops. It stops the loop. Now, I already mentioned about split horizon, but a little bit more on it. A network should never be advertised back over the interface that it is used to that network, right? So again, I received a route on this interface. I'm not going to advertise it back out that interface. There's a couple exceptions, and that's the physical frame relay and ATM interfaces. And then you could see actually if split horizon's turned on by doing the show IP interface command. Again, with poison reverse, it states a network shall always be explicitly advertised as unreachable over the interface that it is used to reach it. So then only if poison reverse is implemented in that code. I don't believe Cisco implements that. Yeah, down at the bottom. It's not implemented in Cisco RIP version 2. All right. Route poisoning, basically when a network it fails, then I'm going to immediately poison that route and then send it to my neighbor. And I'm going to send it for 60 seconds by default. The reason why it advertises it for 60 seconds is because it keeps it in the database, and it'll be the route has failed, like it's totally gone, but I'll keep it in the database just so I could advertise it out. And then the math or the time that RIP gets it from, it's flushed after minus invalid after, and then that equals 60 seconds right here. So that's what happens with route poisoning. All right. Big difference between split horizon with poison reverse and route poisoning. Both advertise a network with a metric of 16. However, poison reverse is an extension of split horizon, which prevents routing loops. Route poisoning advertises a truly unreachable route to quickly flush it from the routing table. All right, so that's the big difference. Poison reverse is to prevent routing loops, and route poisoning is rapid removal from the database. And my cat is doing something weird. All right. Triggered updates sent in the moment of detecting a change in reachability to a network. So let's say the metric changed or something like that. So this is made to send it out immediately rather than wait for the update interval to expire. By default, that's 30 seconds. Now, all these timers, when you first see this and you read it and you try to change them in RIP, you're like, what does each one of these do? So don't worry, that's why I'm here. This is why we're doing this together. I'm going to explain to you how all of these work together. All right. So a couple slides back, I told you what Cisco said about these timers: update, invalid, hold down, and flush. The reason why they have all of these is so just in case I don't hear of an update about that route, there has to be some timers and there's some logic that has to be taken. All right. Again, we're doing with routers here and everything is logical. So let me go through these again quickly. Update interval, rate at which updates are sent. By default, 30 seconds. Invalid after timer, 180 seconds. A route is declared invalid when it does not receive an update within this timer, basically like the hold down timer in EdgeRP. After the invalid after timer happens, it counts down to 0. Then we move into the hold down timer state, where it will try to stay there for 180 seconds. This is where you could see inside of the routing table as is possibly down. Now I'm going to start telling my neighbors that it is unreachable. So I'm going to start advertising with a metric of 16. This locks down the routing table for that route. No other routes are accepted until this hold down timer expires. However, this is where the flush after timer comes into play. And this is 240 seconds, which is a countdown as soon as it receives an update. So an update comes in, boom, 30-second timer happens, 180-second timer happens, and 240-second timer happens at the same exact time. Now, After this flushed after timer reaches 0, now new routes are accepted, and it's going to be removed from the routing table. All right. Now, the hold down timer's main purpose is to delay processing updates about a network whose reachability has become questionable, as the received updates might not yet contain up-to-date information. So this is for whatever reason, RIP doesn't detect like a link down between you and your neighbor, but it detects 0 updates. And why would you ever get 0 updates from your neighbor? It could be because ACLs, the router could turned off, and the link, you didn't know via the link. Someone took off RIP version 2 off the process. Maybe passive interface was activated, or the next hop router might not support route poisoning. Whatever the case may be, I have it down here. I haven't heard about this route in a reasonable time, so I'm going to do something about it. And this is what the hold down timer is all about. All right. So here's how it works. A router doesn't receive an update within the update interval 30 seconds. Route is still valid and traffic will still be forwarded until 180 seconds pass, because that's the whole invalid after timer. From there, 180 seconds have passed since the last update, so now lock the routing table. Advertise the metric of 16, tell my neighbors not to use me. This is where we are in the hold down state. Now, the routing table is locked, and I'm in a freeze. When you see hold down state and the hold down stage is happening, we are in a freeze. 60 seconds goes by after we are in the hold down stage. When 60 seconds goes by, we have reached 240. By default, this is the flushed after timer. I'm going to erase that route completely from the routing table, and we will find a workaround or another path if possible. So I have it down here. Therefore, by default on a Cisco router, it should never reach the end of the hold down timer, because 60 seconds into the hold down timer, we have reached the flush timer. All right. I hope that gave you a little more insight on it. But going through these, it was very difficult for me to understand how all of these work. So if you need to rewind this and read every single bullet, because I tried to make this as like a story as possible. Okay. If the flushed after timer is set to anything lower than the invalid timer, so like let's say we were messing with the timers, we kept the default invalid timer of 180 seconds, but yet let's say we change the flush timer to, let's say, 120, the invalid timer takes precedence even though the flush timer is less. So be aware of that. So even if I change the default of flush to 120, it's still going to take 180 seconds for it to be flushed out, because invalid timer takes precedence. And then this is just how this command right here under the RIP process, this is how you could change the timer. Timer's basic, what do you want to change the update to? By default, it's 30. Change it to like 1 if you want to, or 5. Invalid, they say have it 3 times the update interval. Okay, so if I did 5, so then you say 15. Hold down timer, they say 3 times the update interval. So again, 15. Flush, anything higher than the invalid timer. So if it was 15, you could say 20. Doesn't really matter, just anything higher than that. And if for whatever reason something is happening, you want to have a faster convergence, use the clear IP route star command. We've gone over this before. This will issue version 2 request packets, which will cause neighbors to send their full routing updates. All right. That's all I have for you right now for convergence and loop prevention. I hope this gave you a better understanding how everything works. Those timers really trip me up. Fully understanding poison reverse, route poisoning, and split horizon, how they're all different, but yet they still kind of work together but still mean the same thing. They are used in different situations, and you have to understand that at the CCIE level. All right. I hope this was informative for you, and I'd like to thank you for viewing.